Hey there, science fans. Are you ready to explore something truly amazing? Today, we're diving into the super cool world of dry ice. This isn't just any ordinary ice, it's something extraordinary. You know that stuff that makes spooky fog at Halloween? It's the secret behind those eerie effects that make your Halloween parties unforgettable. But dry ice is more than just a special effect. It's used in various industries, from shipping to scientific research. It's actually frozen carbon dioxide, the same gas we exhale. Imagine that the air we breathe out can be turned into this fascinating solid. What makes dry ice extra cool, literally, is its temperature. A frigid -78 degrees Celsius, -109 degrees Fahrenheit. That's incredibly cold. That's much colder than your freezer at home, which usually sits around -18 degrees Celsius, 0 degrees Fahrenheit. Now, you might be wondering, how can a gas become a solid like that? The process involves compressing and cooling carbon dioxide gas until it solidifies. And what makes dry ice so useful? It's perfect for preserving food, shipping medical supplies, and even conducting scientific experiments. Well, get ready to chill out as we explore the science behind this fascinating substance. Stay tuned, because there's so much more to learn about the coolest solid around. So, how do we get from invisible gas to solid, super cold dry ice? It's a fascinating journey that involves some pretty interesting science and industrial techniques. It's a pretty neat process that combines chemistry and engineering. First, we need carbon dioxide gas in a concentrated form. This gas is collected from various sources, often from industrial emissions. Luckily, this gas is a byproduct of other industrial processes, so we're actually recycling. This not only helps in reducing waste, but also makes the process more sustainable. This CO2 gas is then put under immense pressure and cooled down rapidly. The pressure and cooling are crucial steps in transforming the gas. Imagine squeezing something really hard and putting it in a freezer at the same time. The gas molecules are forced closer together and lose energy. What happens? It turns from a gas straight into a solid, skipping the liquid stage entirely. This process is known as deposition. That's how we make dry ice. Pretty cool, huh? Dry ice is used in various applications, from keeping things cold during shipping to creating fog effects in theatres. Before you go playing with dry ice, we need to talk about safety. Remember, it's extremely cold. Touching dry ice with bare hands can cause something called burns, but it's more like frostbite. Another important thing to know, dry ice turns directly into carbon dioxide gas. This is called sublimation. While CO2 is all around us, too much of it in a closed space can displace oxygen, making it hard to breathe. So always handle dry ice with gloves and use it in a well-ventilated area. Safety first, science fans. Section 4. Keeping things cool with dry ice. Now that we know how to handle dry ice safely, let's talk about its superpowers. Dry ice is incredibly useful for keeping things cold, even colder than your regular freezer. Think about transporting vaccines or medicines that need to stay super cold. Dry ice is the perfect solution. It's also great for keeping food frozen solid during shipping or even for camping trips. And here's a cool fact. Since dry ice turns directly into gas, it doesn't leave any messy puddles behind. No more soggy sandwiches. Section 5. Dry ice, the future of cool. In this segment, we delve into the fascinating world of dry ice and its myriad applications. Dry ice is more than just a cool way to make fog. It's a substance that has captured the imagination of scientists and innovators alike. It's a versatile substance with tons of potential. From the food industry to the medical field, dry ice is making waves. Scientists are even exploring its use in cleaning delicate surfaces where traditional methods might cause damage. And in the fight against climate change, dry ice is playing a crucial role by capturing carbon dioxide from the atmosphere, helping to reduce our carbon footprint. As we continue to innovate and find new applications for dry ice, the possibilities seem endless. One thing is certain, this super-cooled solid is sure to remain an important part of our world for a long time to come. Its unique properties make it indispensable in various sectors. So next time you see dry ice in action, whether it's in a science experiment or a special effects display, remember the science behind it. The process of sublimation, where dry ice turns directly from a solid to a gas, is a fascinating phenomenon. It's a fascinating example of how we can manipulate matter and harness its properties for practical uses. From cooling to cleaning, its applications are vast. And as we continue to explore, we find even more innovative uses for this incredible substance. Keep exploring, stay curious, and always remember science rules. The future of cool is here, and it's powered by dry ice.